These guide notes are going to be for October 27th, October 30th, and we're looking at what we call the law of sines, and that should also say law of cosines, to solve for angles and side lengths of a triangle. And what we did to start class is we looked at these two triangles, and we said, hey, can we try to figure out how to solve for x here, and can we solve for little a here? When we looked here, students said, well, this is the angle that we're solving for. In relation to this angle, we're given the adjacent side and the hypotenuse side. Since that's the case, then we could say that tangent of x is adjacent, not even tangent. What am I saying? Cosine of x is adjacent over hypotenuse, so it would be 109 over 134. And in class we also talked about here what we're trying to do is get x alone. So we have this cosine in the way. We need to figure out how can I move cosine to get rid of it so that I just have x on the left hand side. And some students say, hey, we can just divide by cosine. But cosine is a function, so we need to think about when we're solving and we have a sine or a cosine with the x like this, cosine of x, we need to think about what is the inverse of cosine. And the inverse would be arc cosine. And so because arc cosine, if I do that to this side, would eliminate the cosine, then I would just have x. And on the right hand side, we have arc cosine of this fraction. And that should be arc cosine. I had to squeeze it in there. But arc cosine of that value, and that would be our solution. Another way you could write this is using what we call inverse notation by saying cosine inverse. We're talking about the exact same thing. So anytime we're trying to solve for an angle, which is what we're doing here, because our inverse trig functions arc, cosine, arc, sine, arc, tangent, because there's always output angles, you'll have to use one of those to actually solve for the angle as we did in this case. In the next one, we were trying to solve for this side length. And some students said, hey, I have two sides. I'm trying to solve for the third one. I can just use Pythagorean's theorem. And some students said, well, if I have this angle, I have the opposite, or let's call it the adjacent. I'm trying to look, or the hypotenuse, I'm trying to look for the adjacent, so I can use SOHCAHTOA. The problem here is with these two things, Pythagorean's theorem and SOHCAHTOA, what's happening here is these are only applicable for right triangles. So we can only use these for right triangles, which we don't have here because of that 85 degrees. That's telling us we do not have a right triangle. So in class we talked about we need something new. We need a new concept, a new tool to use so that we can solve for sides and angles if we do not have a right triangle. And what that is called is the law of sines and the law of cosines. Now these look a little scary. They're not too bad. I'm going to explain a little bit some of the pieces here and explain things about the triangle that hopefully you have on your guided notes. But here's what the law of sines says, and here's what the law of cosines says in relation to this triangle. A few things to notice here. All of your capital letters, those are going to be the angles of the triangle. So notice here you have 1, 2, 3 angles you could use for law of sines, whereas in law of cosines, you only have this one angle that you can use. So that's a really big difference in terms of when you're going to use law of sines versus law of cosines. Another thing that we need to notice is here's capital A, or big A, as I like to say it. Little a is directly opposite of it. Little b is directly opposite of big B. Little c is directly opposite of little c, or little c is directly opposite of big B, or big C. Sheesh, there we go. So we can label our triangle any way we want as long as the big letters are opposite of the little letters and vice versa. Also, all of our big letters will be angles, all of the small letters will be sides. Okay? Now, a huge difference, I recommend making a note on the side, because I will not tell you to use, hey, use law of sines here. Hey, use law of cosines here. You'll need to be able to determine the difference. Huge difference here in law of cosines, again, only one angle. So either we're going to be given one angle or be asked to solve for one angle, but we're not going to have any information about big C or big B. Versus if we have multiple angles, for example, if we have angle A and we're asked to solve for B, or if we had angle A and C asked to solve for any of the sides, we could do that. Because if we have multiple angles, then we can use law of sines. So for example here, I'm going to try to keep the law of sines and cosines at the top. Here we want to solve for this angle X. Now, I'm going to set up two equations, and I'm kind of to talk through the difference between the two. So here, law of cosines, I'm going to bring that here. So if I plug, another good thing might be to label the triangle, right? Let's call this big A. Let's call X big A, which means that 22 would be little a. Let's call 42 big B, which means 17 would be little b. Big C, little c. Now, if I'm looking at law of cosines, if I plug values in, I'm just going to take everything I have in the triangle and plug those in. So instead of little a squared, I'm going to have 22 squared equals 17 squared plus c squared. We don't know what c is, so that's going to stay as c squared minus 2 times 17 times c times cosine of a, which is our x value here in this triangle. So I'm going to write that as x. Again, I'm taking the values here in the formula, plugging them in as they relate to this triangle. Now, if we plug in law of sines, here be sine of big A, or in other words, sine of x, because that's our big A in this problem, over 22. Little a is 22, equals sine of 42 degrees. Little b is 17. Big C, we don't know what that is, so we'll keep that as big C. And we don't know what little c is either, so we'll keep that as little c. Now, what we talked about in class is here we need an equation where we have only one unknown, and if we have that, then we can solve. And oh my goodness.
You're in the library for a panel conference, please. Mr. Ortner, if you would please report to the library.
So if we look at this equation, what we also talked about in law of sines, you're never going to use all three. You only need two pieces of it. And what students recognized is if I ignore the C's, so if I put my pencil over it, and just focus on the A's and the B's, well, then I only have one unknown. My only unknown is X. Whereas if I look here in the law of cosines, if I look at unknowns, I have a C that's unknown here, C shows up again here, and X. So I have two unknowns in law of cosines. We cannot solve this explicitly. We will not be able to use it because we have two unknowns. In contrast, here, law of sines, we only have the one unknown being X. So here we would not use law of cosines, and we would use law of sines by ignoring this piece. So now we have this equation, and we want to solve for x. Well, if I have sine of x here, the ultimate idea is to isolate the sine of x and then do something to get rid of the sine. So if I want to isolate sine of x, I can multiply both sides by 22. I'm going to write it as a fraction here since I have a fraction. Write it as a fraction over here as well. These 22s would divide out. We're left with sine of x equals 22 times sine of 42 degrees over 17. And then here we have the sine of x isolated, which is what we want. Now we just need to figure out how to get rid of the sine. And what we have to refer back to is what we did up here. We had the cosine. We wanted to get rid of it, so we used arc cosine. Similar thing here. We have sine. We want to get rid of it, so we'll use arc sine. And our solution will ultimately be arc sine of all of this, which doesn't look pretty, but because our calculators that we are using can't calculate it, that would be your solution. If you have questions, please, it's new, ask questions, love to answer those. But just real quick, here, the idea is that we hopefully could see that we would use law of sines from the get-go. Why? Law of cosines, we only have one angle. Yes, we're solving for one angle, but if we're given this other angle as well, chances are, not every time, but chances are we can use law of sines to solve as we were here, because we have this angle, we're trying to solve for that one. We have the sides opposite of those angles, so we can use law of sines. In the next video, we'll look at the problems on the back side, see if we can solve some of those using law of sines and law of cosines.